Okay, we're gonna continue our adventure here through linear equations, and we've got graphing absolute value equations. Now you got to recall here, like in our last lesson, general transformation rules. Transformation just means moving. So general transformation rules for absolute value graphs. So here's a couple things. So if we have our parent function, which is y equals the absolute value of x. We've got a couple things going on down here. Now, go ahead and read through all this, but I'm going to go ahead and label some things down here at the bottom with our equation. So y equals a times absolute value of x minus h plus k. If you have a coefficient here, what your coefficient is going to do is it's going to change or alter. It's going to transform the size, and it's going to determine if it points up or down. That's how that influences it. The h is going to influence if your absolute value graph is going to move left or right. And your k, what's being added on the side, is going to influence if your graph is going to be up, if it's going to move up, or if it's going to move down. So some things to keep track of as your absolute value graph moves and transforms all over the place. We got to take a look at this guy though. Just keep in mind, in this situation here, it's kind of the opposite of what you see. So if it's negative, it's moving to the positive, to the right. If it's positive, it's moving negative to the left. And that's because of that absolute value feature. And same with the size, with your A. You have to keep an eye on this one for the positives and negatives, which way it's going to point it. Positive will move your V up, and negative will move your V down, like invert it a little bit. And the size also is influenced by the number, which is really interesting. So if it's a number that's greater than 1, as we can see here, if your number is greater than, actually it's right here. Yep, if it's greater than 1, it's going to be narrower. And if it's less than 1, it's going to be wider. Kind of the opposite of what it seems. So a couple things to keep track of when you're doing that. So if A here is greater than 1, 1, 2, 3, 4, 5, 6, if it's greater than 1, it actually is going to be a narrower graph. But if A is like a fraction, so anything less than 1, it actually creates a wider V. Your graph ends up being wider. Let's take a look at the parent function again. 2, 1, 0, 1, 2. We want to make sure we have a good starting point. It does go through the origin, goes through 1, 1, 2. I'm going to draw a line, because I want these to be more accurate. Get arrows in the end. There's a good looking parent graph here, and as this parent function, we can transform different things to it, like for instance here. So we're going to influence it this way. Now remember, this particular one moves it left or right, so it's either going to move left or right. When I look at this one, and it tends to be the opposite of what it is. I'm going to play this out. So I already filled everything in. So -2 minus 4, -6, the absolute value of -6 is 6. I'm going to press pause and fill the rest of this out. All right, I filled it out, plotted my points. I included a few more points over here on the right side with x being 3, 4, and 5, just because I want to see where my graph changes. So 3, 1, 4, 0, and 5, 1. And this is where my graph turns, makes the V this way. Okay. A couple things I want to indicate here. As I'm looking at this, I can see that the size of my graph does not change. The coefficient is positive, so my V is going to point up. There's no constant kind of happening over here on the side, so it is not going to shift the graph up or down, but indeed shifts it, as indicated here. It shifts it 4, 1, 2, 3, 4, to the right. So a -4 is telling me that it's shifting to the right 4. And in fact, it's my parent function shifting over. So when I look at this graph, I can see that something's happening here. I can already kind of look here, and maybe you can, kind of think ahead a little bit. The coefficient, that's going to tell you something. You should see this and go, okay, compared to the parent function, the size did not change. The v does point up. I can see there's nothing going on in the absolute value, so it tells me that this will not shift to the right or the left. But this tells me something, that it indeed will shift up or down. And in this case, we can kind of either make a prediction on this one. I'm going to press pause, finish out my t-chart, start some plotting, and let's see how it goes. All right, I can see on my graph here, I plotted out that it is a replica of my parent graph. The graphing has not changed, but indeed it just shifted down by 3. And I can even see that by the negative. Some things we can start to tell in advance. Let's keep going as we do some more translating of our parent function. Okay, look at the coefficient, see that it's positive. I see the size did not change. I see that there's no constant here, nothing being added or subtracted, so that's going to keep it from moving up or down, but indeed is going to move left or right. It's a positive 3, so, and it's an absolute value, so I'm going to be thinking left, and looks like 3 from my parent graph. So if my parent graph starts here at the origin, I can really just shift over 3. 1, 2, 3, and it's going to replicate my parent graph. So it seems like it should be right here. I'm going to press pause, run out my t-chart, and plot everything in red, and we'll see if it matches. All right, I plotted out the red points on here. On the right side over here, I included a few more points because I wanted to take care of, kind of see where it starts to turn. And I can see -3, 0, and I can see -4, 1. So my graph indeed is my parent graph, but it just shifted to the left 3. Here's another one, so I can take a look. Some things I want to start to notice. Look at my coefficient. Notice that it's positive. It's going to point up. It's not doubling or it's not halving, so we can see that it's going to be a replica of the parent graph. There's nothing going on inside the absolute value when that shifts at the left or right. So this is something that is going to be shifting up or down. Up or down. And I can see because of the positive here that it should be shifting up by 2. And because it replicates my parent graph, I can go 1 and shift it up 2. I'll plot it out like this. And it should follow this line. I'll press pause, work out my t-chart, and see if that is the case. When I do plot it out, the blue actually does follow the green lines, showing me that this, I was right. It's the parent graph, but shifted up 2. All right, this is when it's going to get some real interesting. We'll kind of work out the first few examples. Writing an absolute value function. So I gave you from the parent graph, so I will do number 1 together. Okay, let's do number 1 together. So from my parent graph, I'm going to move it 8 units to the left. I don't want to change the size of it, so the left is something happening inside here. So equals x, and I want to move it to the left, which moves it negative, so I'm going to do +8 inside. And this is my parent graph shifting 8 units to the left. I'm going to try number 2 with you. Actually, I'm going to do number 3 with you. Okay, so it's the parent graph, the parent function, and I'm going to move it 5 units up. So I don't have a coefficient on this one. Now 5 units up, that's going to be something that's added on here, and that will shift me 5 units up. All right, I am going to press pause. I would like you to do the remainder of the problems here and press play and see how you did. So press pause now. Pause, pause. It's the one that looks like the number 11. The number 11, pause, pause, pause. All right, take a look and see how you did. Your answers, and up and down is just that constant that's being added at the end of the equation. Right and left is added inside the absolute value, but just the opposite of it. Oh, missed some. All right, write an equation for each one of these. Okay, so we've got a couple different things happening here. So I'll do number, we're doing 9, 10, then 5, then 7. Why not? Let's mix it up. So let's take a look at what we're doing. All right, I want to move it 2 to the left. So I'm going to do that, and I want it 4 units up. So this should move it 2 to the left and 4 units up. Once you press pause and try 10, 5, and then 7, and let's see how you did. Pause. All right, take a look, see how you did. Paying attention of these two transformations. Remember, there's that third one that can change the size of it. And in this case, number 10 and number 5, we did have a transformation happen. The coefficient is still 1, so it doesn't change the size of it, but the negative sign does change my v. My v points down. My graph now points this direction for number 10 and number 5. All right, there's another type of graph we want to pay attention to. The absolute value function is an example of a piecewise function. A piecewise function is a function that has different rules for different parts of its domain. So different rules for different parts of the domain. For example, when x is greater than 0 and the absolute value of x is x. When x is less than 0, the absolute value of x equals negative x. The other piecewise function is a step function. Okay, and this is really the focus of what we're talking about here. It's less about the piecewise function and more just about seeing how a step function works. It's where a pair that pairs every number in an interval with a single value. Okay, and it ends up looking like a staircase. Each feature of the graph is a horizontal segment that is missing its right endpoint, indicated by an open circle. So we can see in our graph over here, there's our data point, and that information is true all the way to here. We have an open point because the information jumps up here. This might be, we'll look at a situation next, but this might be like price for a pizza, so if you want to graph it, actually that's kind of a silly example, but if you order one pizza, it's going to have this one price no matter how much you eat. But when you start getting to like 2 pizzas, the price still is going to go up. Now that is actually a really silly example, but when you go to a pizza place and order a pizza, actually that's a really bad example because you're not going to order a pizza and a half. I want to use the example they show us. And then we can come back to the pizza one. I'm sure we can make that pizza one work. You sit, it's a chin scratcher. I know you can make it work. There's a scenario that can happen with buying pizzas, eating pizzas, and then sneezing. A school needs to charter buses so the student body can attend a football game. Each bus holds a maximum of 60 students. So anytime they have a student, we need to order a bus. And when it gets up beyond 60, then we need to order more buses. Oh, that was kind of cool. Whoa. I have fun lines all over. This is fantastic. You're going to need 0 buses for 0 students. Okay, that kind of makes sense. Nobody comes, don't need any buses. As the number of students increase, the number of buses goes up by 1 every time we go in the multiples of 60. So every group's of 60. So this is how it plays out. Let's see if I can move this without drawing circles here. This box number 2 really moves. Let me unlock it. There's our graph. And we can see right here, 0 students, 0 buses. But as soon as 1 student shows up, then we need to order a bus. And when it gets to 60, it is full. And that actually ends it. It's done, end of point. And then we have to order a second bus as soon as we get to 61. And then that fills up, and there is an end point on that one as well. That ends. And then we need to order a third bus. Okay, so when it comes to working with these step functions, a couple things to keep an eye on would be which dot to use at what point. Recognize that as the information moves along, it does not move up. It's not a linear relationship moving up. There are certain steps that play along with that. I want you to try it on this one. And again, be careful the dots you use. So read the scenario, press pause. All right, let's take a look here. Number of students, now the bus situation with 50 students. So 0 students, 0 buses. 1 starts coming, and then as soon as you get to that 50th student, it ends, and then we have to order another one. That's what that graph will look like. All right, there you go. Continue to practice this stuff. All right, I'm going to go and take my socks off and share them with a friend.